All right, so do stifle yourselves. So our goal for this video is to put everything together. And the way it's going to work is somewhere along your tabs at the bottom. You probably have one that says assembly. And oh no. How does this I got why does it do that? Okay, so you probably have one across the bottom called assembly. And that is where we're going to do the assembly. If you don't, for some reason, you can get a new one from the same place that you got new parts from, insert new element. But either way, this is where we are going to do this. And the general process for assembly is bring in a new part, constrain it using the various constraints here, and then bring in the next part and so on. And usually we'd start with whatever the base is, or like the main piece. And I think for this project, train body is the main piece. Could argue straight track, but we're gonna start with train body. So you're gonna go to assembly and insert, and you should be able to choose from, oh man, what's going on here? I'm gonna do full screen, maybe that'll help. Insert from your options. If you are using other, like you built your parts in multiple files, you should be able to go to other documents, I think, and jump back and choose it from there. It will require you to create a version. And what that will do is copy it into your whatever document you're using for the assembly, so that it if you change the original, it doesn't mess with this one. At least that's my my understanding of it. Either way, hopefully you have all of your stuff in current document. And let's go ahead and place the train body and place it wherever is fine. And we only want one of them. And the first thing we're going to do is right click on it and fix it. Okay, fix as in affix, as in tie down and lock in place. That's what we want. And we don't really need the origin point for visibility or for constraining anything, so we'll get rid of that. And now let's put in the next thing. Let's do the hitch magnet and hitch peg. So hitch magnet, we want one of those, so we'll click on that, click to set it, check mark. And the way it's going to work is we want a cylinder mate, I think, and we want to choose where they connect, which in this case is going to be, you can see how, depending on how you're looking at it, the different, like that's back in the hole and this is sort of at the front of the hole. You have to think about the faces that you want connected, which in this case would be that one and hold on a second. And okay. No problems. All right. So let's do that one from beginning. So we have two parts in. We have the train body first and then the hitch magnet. And right now it's not constrained at all. I think the best plan, like I said, is slider mate. And the two areas we want constrained are going to be that face and that one right there, and that should pop it over. But we don't want it sort of on the inside, so we're going to switch directions, which is this one right here. Hit OK. And I think it's still going to move out. Yeah, so let's do planar constraint or mate. And the faces we want are essentially the same two. And that's not what we want. Let's undo. Still working on what the animate thing does. But either way, when you're done, you should be able to grab it and have it not move at all. It still will spin, even though you can't really tell that it's spinning. I think it still spins. Either way, we'll find out with the wheel whether or not that works that way. So we're going to do the same thing with the hitch peg. And we want just one of those. So we'll click to set it out in space. And that's it. Then we want another slider mate. And that face. And the plane or rounded part that's going to connect is this under. This part right here, not the outside. That would have it stick out. We want that one. And let's see what happened. And it's facing the wrong direction. That's fine. We'll switch. No. Yeah. And hit OK. And there you go. That's what that looks like. Okay. And let's do cow catcher next. Why not? Cow catcher. We just want one of those. And for this one, there's a bunch of ways to do it, or for any of them, a bunch of ways to do it. I want to do, let's see what happens if we do this in the reverse order. Plane, that face to somewhere on there. Okay, but we don't want it inside, so we'll go like that. Hit OK. And next, let's do the slider mate, which is the cylindrical one. And let's just do it to this top center. But the top center one, which is upside down on this one, but it's this face. You can see where I'm clicking. It's this face sort of along the flat part of it. And hit OK. And now it should spin around in theory. Strange. Which is the one that keeps it from Let's not do the planar one. Why is it not spinning? Or why is it spinning? Let's try parallel the bottom of the train with the bottom, something flat on that. And let's flip direction. Hit OK. And then it should still move out. Okay. So it's just about picking what directions you want to keep from moving, essentially. So the parallel one lined up the bottom. Did it break the other one? Let's see what happens when we delete this. And that's still going to move around. How do you do this? Let's see what happens if we slider mate after we've done this. Still move? Why does it still move? It still moves out. Shouldn't do that. Oh. I guess it doesn't really matter since we're not going to be animating it as long as it looks right. All right, well, let's just go with that for now. This is frustrating in its limitations compared to other. What if it's cylindrical mate? Well, let's try it with the wheels. I would say for wheels, just bring in 2 of them. And we'll just work on one side. Let's see if cylindrical mate is the one I'm looking for. I want that with something cylindrical there. Let's flip direction. And it's sort of on the inside, but we should still be. Yeah, there we go. Okay. So cylindrical mate is the one for something that we want to still essentially be able to spin, but lined up with the axis. Then why is there not? I don't want fixed mate or fastened mate. Let's see what plane does from that to that. Does that break the cylinder? Does it still spin? Oh, okay. So we want cylinder spin, or cylinder mate is the one that we want. Okay, and we'll do the same for both of these. Let's do cylinder mate. Slider mate? No, cylindrical mate for this part and this. And we want it to go that direction. Hit OK. Still should move out. There we go. And then plane with that connected to that. Okay, then these should still spin. And so let's try the next side. Other thing would be linkage arm. And let's just do one of those. I want to redo cow catcher because I think the cylindrical mate is a lot better. Let's see what happens if we do 2 cylindrical mates, because this surface right here needs to line up with this, and we don't want it sticking out. We want it like that, flat against. And then we want it also to do the same thing to this side. And so let's do another cylindrical mate of the same sort of outermost part to the outermost part, I think. Oh, strange. That shouldn't happen. Oh yeah, there we go. Pops back in. And then this should still move to line up, but we need it to be like attached that way. So let's do a plane, and we want the outermost with the outermost. And I think it's strange that that pops, but when we hit OK, it should resolve it. There we go. Okay, so now you should be able to grab this and it should spin without coming off of the train. And the last portion of this side is linkage peg, which we need 2 of. All right, so this is making much more sense. So let's do cylindrical with the hole for the linkage hole, which is this one, but making sure to get like the outermost part. And when the peg is all the way in, it lines up with that one. And we want it not sticking out. We want it reversed. So it's like that. Hit OK. You should be able to grab it, pull it out a little bit. And then we're going to do the plane of this one to that one. And again, it pops out, but we should be fine. Hit OK. There we go. All right. So this is coming together. And the same thing here. Let's do cylindrical of this one. And double checking to make sure that it's going the right direction is not. So we'll flip the direction. Check mark. And it still pops out. So plane. And then the parts that'll be touching, which are this one and this one. And hit OK. And it resolves everything. And there you go. That's one side. I guess just to reiterate, I'll fly through the other side. And hand is not good. Okay. So we need 2 wheels to start. And we want cylindrical, and we want this outest portion and the part it's going to touch. and hit okay. Guessed the correct direction this time. And then plane. And that part is going to touch. You have to find very specifically where your mouse goes in order for it to choose the right spot, but it's that one. And making sure it's going the right direction, which is that way. So all the curves and stuff are on the outside. And close this and do another cylindrical. I don't think it matters which one you do first, whether the hole on the body or the one on the wheel. Hit okay. And then same thing. Plane for there and for there. Okay, let's do another linkage arm. And same series, cylindrical. That lines up with this outermost part. And that can line up at this point with any side of this, because that's the only thing we have. And let's do the plane, which this side is going to be on the outside there. Okay. And then it should just move and we need to attach it. It's not moving the way I thought, but that's fine. There is the possibility, and I think I can get this to break on purpose. If you have your things lined up like this, where they're sort of like closer, the connection points of the linkage arm are close, it might bounce to or guess to the wrong direction. And if we hit okay, that's fine. That actually works. Because you can drag it and line it up that way. So that's fine. And then we need 2 linkage pegs, 2 more for this side. And cylinder. It goes here on this outermost. And let's make sure it's going the correct direction. And it is going the correct direction. But we still need a plane. Okay. And same thing for the last one, a cylinder. This goes with that check mark, and then plane of this to this. It pops out, hit okay, fixes it. All right. So only 2 other parts, and that is the smokestack and straight track, I think. Oh no, axle peg. Should we break this up into 2 parts? No, we can do it in one. You can just spend more time doing it. Okay, so we need axle pegs, same thing. And we need 4 of them. We'll just go and do all 4 of them at the same time. And same cylindrical. This one goes to there. And it's going the correct direction. It's this one. and plane. Okay, and cylindrical here. I'm going to get this out of the way for now. Cylindrical. That one. Do that one. There we go. Check mark. Yeah. You probably don't need to drag it out of the way in order to get the plane constraint, but it certainly makes it easier. And on this side, yeah, on this side, you'll notice that everything guessed wrong. And that's because it has to do with positive and negative for the origin plane, which is fine. But everything on this side of the train required a swap direction, and everything on the other side didn't. That's not a coincidence, but just be aware of what is what. And one more. Cylindrical with that to that. Switch direction. Check mark. Ouch. And plane. Okay, and so let's go ahead and do smokestack. And smokestack is about the same, except the key is that the only plane you can constrain to is the surface that's down in there, because the outer ring is not a circle, even though it is sort of circular. Because it travels on the path of the cylinder boiler part, it's not going to do that. So we're do the same thing, except just with the stuff that's flat at the bottom. So we need a cylindrical constraint with that's centered on that. And that portion is what's going to touch that. And takes a second to solve. Check mark, and then drag it out to do the planar constraint. And the same two portions. And check mark. Okay, almost done. This shouldn't move now. Good. All right, so this last one, we're going to try and figure out. I'm not entirely sure how it's going to work. Straight track. Check mark. And let's do how do you, it's a tangent parallel. Let's just get it pointed the correct direction. So let's parallel this face with this face. And it's struggling now. Oh, there we go. So let me try again. Parallel constraint, this with this. Wow. Is the internet broken right now? Let's try one more time. Oh, weird. Why is this like that? That's strange. Let's see what my linkage are, my straight track. I wonder if I made something wrong. Oh. If you followed exactly, weird. Why would it be like that? All right. Well, there might be a fix for this later, but let's get rid of that for now. And is that this one? Yeah. Okay, so for now, let's just pretend like this is what the straight track looks like. Maybe that was the issue. So let's go ahead and do parallel. That face to that face, and that really shouldn't be a huge constraint. It's just going to get it going the correct direction. And let's get it flipped up. A lot of this is just so that it can guess which is the correct direction for the next constraints. Parallel that with that. And let's see, is it going the correct direction? It is. Okay. And so we can figure out, let's do a planar constraint of, see if we can find the center point of that to the center point of that. But we need an offset. We haven't done this yet. And we need an offset so that the wheels don't dig in, which I think might be like 0.4 or 0.5 or negative 0.4. Yeah, let's just do negative 0.4 for that. And does it still move is the question. It does. Let's do the same thing, but for the side planar. Do this side to this side with an offset of, I think it's like 0.7 maybe, just from past experience, or negative 0.7. And let's see if this breaks it. Yes, it does not break it. If you click in the wrong place, this left side will be like red, or one of these will be red. I think it's probably still going to slide front to back. Yes, it does, which is probably fine, but let's just go ahead and do it right. Constrain this face to this face, and it shouldn't matter where you click. It will jump to line up exactly. But let's try an offset of like what 2 inches does. Wow, I've guessed wrong every time. Let's try -2. Let's try -3. We go, and check mark. Okay. And when you are done, you should be able to grab anything and have it not move. Oh, speaking of which, let me redo the cow catcher. I'm just going to delete the cow catcher and place a cow catcher. And we'll just do the same step. Cylindrical of this part of that top center nub to the outer part of that one. I don't think it chose the first one. Yeah, there we go. And we don't want it going in. There we go. Okay. And let's do to make it upside down, let's do a parallel of anything that's flat going this direction. There we go. Like that. And we want it parallel to something flat. I'd prefer something underneath the train because that is not going to move. And we want it that direction. We want it going up. And even though it's sort of wrong, it's like that. There we go. Okay. And then the last part is just the planar maze, which is just like before. We just need something that's flat there to something that's there. Hit okay. And in theory, you should be able to grab anything except the wheels or linkage arm, and it shouldn't move. That's how you know it's fully constrained. Let me see if I can figure out. I don't know why the straight track is not doing that. Why it's counting it as two parts. Why is it making it a new part? All right. Well, I'm not sure why it's making a new part. I'll work on it and see if I can solve it. But for now, as long as something that looks right like this, you're good to go. And that's it for the assembly.